This video lecture is about aggregation in the SQL DML language. The major source for this material is the textbook, section 3.7, but you will want to look at the reference manual on aggregate functions. The learning outcomes: you should learn about the basic operation of built-in aggregate functions and a little bit about user-defined aggregate functions, although we won't cover that in any significant way, the group by operation, and the use of having. The one thing we will not learn about is the use of aggregate functions in cases of multiple SQL tables, or in particular in the case of subqueries. That will be saved for a later date. Okay, the original 5 aggregate functions: average, min, max, sum, and count, which are more or less exactly what you would expect: the average, the minimum, the maximum, the sum of values, and a count of values. A point on this: average and sum have to be over numeric data. Min and max don't have to be. Count doesn't even have to be over a single column. There are many other aggregate functions. You will have to look them up in the reference manual if you wish to know about them. But briefly, there are bitwise operations. This in particular, bitwise XOR, is rather useful if you want to create checksums over data. There are standard statistical functions, standard deviation by population or by sample, and the variance by population and sample. There are a couple of different names for those functions, but those are the names I have here are the SQL standard names. A group concatenation, if you want to concatenate a number of things together, and a couple of JSON functions that'll create JSON aggregate objects or great JSON aggregate arrays from the data. If you do not have a built-in function that you want, create your own aggregate function. We don't do this in the course, but you should be aware of it because creating your own function may be necessary under certain circumstances. Less with aggregate functions, more with non-aggregate functions, which we haven't covered yet. Operation of aggregate functions. So they operate in general on the values of a column. The count operation and the JSON operations can operate over multiple columns. The others operate over the single values of a column. Anything that's a math function obviously requires numeric values. Okay. They will return a single value of the relation in a simple operation. If you wish to eliminate duplicates, for example, if you're counting things and you don't want to count duplicates, use distinct within a function. So let's have some examples. Let's say we want to find the average salary of instructors. Select average salary from instructor. What if we just want the average salary of physics instructors? Select average salary from instructor, where department name is physics. This from clause starts with the instructor relation and uses the predicate after the where in order to reduce the relation according to this predicate. Only the rows that satisfy the predicate will be left in the ultimate relation. And then the average will be calculated from that. So, to put it simply, we start with instructors, and there'll be, what is there? There's ID, name, department, salary. And so we start off with whatever the ID is, Einstein, and he's in physics, and he has a salary of whatever. Mozart is in music, etc. So we have this relation to start with. That is transformed by the where clause into, it has exactly the same set of columns, ID, name, department, and salary. But it will eliminate, so we'll still have Einstein here. and physics and 1, 2, 3, but we won't have the Mozart relation in there, so we'll get rid of Mozart, and you imagine that instead what you have is, oh, I don't know, Niels Bohr, okay, is also in physics, whoops, and he's got whatever salary he's got. In other words, this entire column will be physics, because the where clause says that, okay? From this, we then hand it over to the calculation of average salary, which means the average is being computed over this column only where the physics is true. So we've taken a relation here. Let me... just a minute. We've taken this relation, we've transformed it into this relation with the where clause, and then we operate the aggregate function over that new reduced relation. This is called a derived table. D-R-I-V-E-D. Okay. We may not have an actual version of a derived table with that simple a thing, but it is conceivable that you will. Certainly there are derived tables in certain contexts. So, that's what happens there. What if we want to find out how many departments there are in a university? Well, count the number of departments from the department relation. Count department name. Okay, and we're assuming that department names are unique. I don't know of any organisation that would have two departments with the same name. If they did, there'd be a department ID that would distinguish them. How many departments have at least one instructor? Now that's slightly more difficult. And it's slightly more difficult because this is the total number of departments, but if there's a department in there with no instructors, I don't know, maybe you've got a department of, I don't know, anthropology, and the last instructor just resigned, and so there's nobody in anthropology at the moment. Well, we could select the department name from the instructor relation, but the problem is, as we see here, there's multiple instructors in physics, for example. So if we want to count them, we can count the department names from the instructor relation, but we will only count distinct department names. So by having the distinct clause, the distinct aspect in here, we will only count each department once, and they will only exist here as long as there is at least one instructor in the relevant department. Okay. 2 points that are worth noting. Number 1, the aggregate function name is case insensitive. Don't ask me if that's true for user-defined functions. I don't know. I suspect it is. But it is definitely true for all of the built-in functions. The second point, and this is an important one, avoid any spaces at all between the aggregate function and the open parenthesis. If you have a space between the aggregate function name and the parenthesis, so for example, if there's a white space in here, your SQL will be wrong, but the message will be confusing and misleading. I simply mention that because that is a debugging problem that more than one person has experienced over the years. Okay, we can group things when we do aggregation. So, what if we wanted the average salary for each of the departments? Now over here we were able to find the average salary for physics, so maybe we could do a query for each department. But then we'd have to know which departments, how many departments we had. If we were writing a client program, it would be a really bad idea because we'd basically have to select the department name from department, okay? And then we'd have to do for each dept in-depth name, which you can't do. You'd have to do a select, and you'd select the average salary, okay, from instructor where depth name equals depth, whatever that depth is. You'd have to write this in whatever client language, and for however many departments you'd have a separate query going across to the database. So if there were 50 departments, you'd have 50 queries as a result, plus the original query. So this is undesirable. So what we do instead is we have this group by operator, which allows us to say, here's all of our instructors in their different departments. Give us the average salary from instructor, but we're going to throw in one of the column names. In this particular case, it's the department name we want associated with it. And we will group by that department name. And the result is we get for each department the average salary for that department. Now that's an incredibly valuable function. This is a rather simple example. Let's imagine we had something that was, say, you had Canada, a database of information about Canada, and you had provinces, and you had cities, and you had information about stuff. You could imagine doing a select, average, whatever, and it doesn't have to be average. It could be standard deviation or variance or whatever other thing you want. How many instructors would be in each department, for example? Select department name, comma, count instructor from instructor, group by department. Okay, so in this particular case, you could imagine select from this Canada table, group by, and you could imagine having province in here if you wanted to get aggregate data by province, or you could imagine saying, wait a minute, maybe I don't want province, maybe I want city, and group by city. Or I could group by province and city, and also I might want to do order by province, comma, city. So I could imagine saying, okay, give me the breakdown of this information by city and by province. So that's aggregation and grouping, except there is a little requirement. Okay. The attributes in the select clause outside of aggregate functions must appear in the group by list. Okay. So if you notice, this has to appear here. Okay. Now, I've got a sort of, there are a couple of exceptions to this, okay? One of the exceptions has to do with functional dependencies. We haven't talked about functional dependencies yet, so I'm not going to talk about it here. That is a legitimate one, okay? There is a separate place where it can be done. I'll talk about that one in a minute. So, select department name, comma, average salary from instructor, group by department name. The SQL standard will reject this. It is unacceptable. It will be rejected, and MySQL 5.7 and later will reject it. MySQL 5.6 and earlier accepts it. Even in version 5.7 and later, it is possible to override the functionality by changing a particular variable. Do not do this. More precisely, number one, if you do this, I will not mark your solution correct. even if it results in a correct answer when you run it, I still will not mark it correct, and the reason I will not mark it correct is because the fact that you got a correct answer was luck. How do I put this simply? Let's suppose we had select department name. Here, we'll erase this material. Select department name, name, average salary from instructor. Suppose we had that, so we'll have a name in here. Now, in the case of biology, it's unique. It would have crick, okay? But in the case of computer science, we've got three possible names. And the name that would get put in there in MySQL 5.6 on earlier is arbitrary. You might think it's the first name in the list. You might think it's the first name that was inserted. You do not know. The database will not guarantee it, okay? So the reason you should not do this is even if you got the right answer, you only got the right answer because you were lucky. In fact, you were unlucky because this is an intermittent bug. It means you've got a bug in your code and sometimes it works and sometimes it won't. And you're in fact not lucky if it works when you run it because you've got a bug there that you didn't notice. So why do I mention this? This is a bad thing to do. The reason I mention it is some students in the past have presented this as a solution as part of their code. Okay, so I'm simply telling you the fact that it exists doesn't mean you should use it. It violates the standard and it's not consistent or guaranteed to work. Okay, aggregation with a having clause. So in the standard SQL query, we have this where clause. And we can use the where clause in order to specify things like find out the name of instructors in the physics department. We would say select name from instructor where department name equals physics. What if we wanted to do the equivalent of where average salary is greater than 42,000? Well, we use having. Okay? Now you might think that's stupid and annoying. Why couldn't SQL just use where? And I will tell you in a minute, but the answer is it cannot. Okay? And if you try to do it using where, you will be wrong. Okay. A second notion of the use of the having clause, which departments have an average salary greater than the average salary of all instructors? Okay, this is comparing an aggregate to another aggregate. I'm not going to answer that. If you want to look it up, you can. You need subqueries or something equivalent to subqueries in order to solve it, and I will address that later. Okay, let's talk about having and where and how they relate. So first, let's talk about which departments, excluding physics, have an average salary of greater than 42,000. So select department name, average salary from instructor, where department name is not physics, group by department name, because we want all of the departments, having average salary greater than 42,000. Okay. This is the difference between where and having. Where is processed before aggregation. So let's go look at this. We have our instructor table, and it's got salary, department, name, ID. Okay, so anything in here that had physics is going to get rejected, eliminated. So we create a new relation, which is the same columns. When I say we, the database creates a new relation, and it will contain all of the data from the original instruction except no physics departments. Okay, so all of the physics instructors are removed. That's that where clause. It's then run through the aggregation, which in this particular case is average, which is going to result in a department name and an average salary. It creates a 2-column table. So we'll have biology and we'll have music and we'll have whatever. Okay. Then, having produced this relation, it then goes through the having clause, which then eliminates the rows so that only those, it keeps the same columns as this relation. This is our third relation. So this is the base table. This is the first derived. This is the second derived from the first, okay, which has a different set of columns. It's got just one department for each, it's got one row for each department, and it's got an average salary calculated there. The having will eliminate rows, so we still have department, we still have average salary, but it will only leave the ones greater than 42,000. So this is the third derived table. Okay. So, where is processed before aggregation? Having is processed after aggregation. One final thing before I finish this lecture. It's something that is rather useful. Average salary as avshal, or whatever name you want to call it, allows you to write the variable name, the new name for that column here, instead of repeating the aggregation. In this particular case, it's not that big a deal, but there are other instances where you will want to rename it in order to be able to make things work effectively. And that's it for the simple aggregation without comparing one aggregate to another aggregate, which, as I said, we will do with subqueries or equivalent.